Today we're going to take a look at arc length and area of a sector. All right, so first of all, we're going to talk about a circle who has a radius of r. So we know this piece right here is r, and a central angle. So the angle that makes that pi piece is going to be theta. All right, so a couple quick definitions. The arc length is the distance along the arc of a circle or a curve. So arc length is this thing that I'm drawing right here in yellow. So it's basically, if it was a pizza, it's the length of the crust. Okay, and then the area of a sector, area is the space in between, so it's actually how much is inside there. Okay, so it's going to be the square feet or square inches, since it's area of that actual entire piece of pizza. Arc length is just the crust, but the area is the whole entire piece of pizza. All right, so let's think about some formulas that we know about circles. Okay, so one of the things is we have to remember that theta is only a fraction of the circle. Okay, it's not necessarily the entire circle. So what is that fraction? So if theta, let's think of it in degrees. If theta was 20 degrees, we would have to take 20 out of 360. However, when we deal with all of the formulas we're going to deal with in this chapter, we need to be in radians. So instead of dividing by 360, that fraction is going to be theta over 2 pi. So we know that the angle is going to be theta over 2 pi. All right, so let's think of formulas that we know about a circle. So I know arc length is very similar to the circumference, and I know circumference is 2 pi r. So what we're going to do is we're going to take that fraction of the circle, we're going to take that theta over 2 pi, and we're going to multiply it by the circumference, which is 2 pi r. All right, so when we go to simplify that, the 2's reduce, the pi's reduce, so we get the formula S is equal to r theta. Okay, so S represents the arc length, and then r is the radius, and then theta is the angle. Okay, so if we think about some possible units of how long something is or how long an arc is, we're going to talk about inches, meters, feet. It's got to be some unit of distance. So we know the arc length has to be a length, or a distance. All right, so if we think about area of a sector, that's going to be a portion of the area of a circle. So again, I can do theta over 2 pi, which is our fraction, and we're going to multiply by pi r squared. Okay, so if we think about, reducing here, I can reduce the pi, and unfortunately that's it. So we get the formula area of a sector is theta cut in half times r squared. I'm going to go ahead and call it 1/2 r squared times theta. Okay, so there's our formula for area of a sector. And like I mentioned before, if it's area, it's going to be something like inches squared, feet squared, maybe miles squared. It's got to be some unit of measurement squared. Okay, and probably the biggest thing that we need to remember is when we are doing these, our angles have to be in radians. So we're always going to talk about an angle not as 20 degrees or 30 degrees, as pi over 6 or pi over 4 or 2 pi over 3. So theta has to be in radians for all of these formulas. All right, so let's go over one more time what exactly a radian is. So remember, a radian, we've talked about, is different than degrees, right? 20 degrees, 30 degrees, 40 degrees. A radian is considered a pure number, and it doesn't have any units, right? So it's just radians. But it can be viewed as the measure of the arc length. So 1 radian can be found by drawing on the side of the circle that same length of the radius. So we're looking at the radius of the circle, and it's wrapped around the outside of the circle, and that's what 1 radian is. Okay, radians make it possible to relate linear measure and angle measure. So we know that this piece right here, say it was 2 inches, and then if we wrapped it around the circle, that would have to be 2 inches too. And we do know from geometry that the central angle has to be the same as the arc length. So that's where we get those measurements on our unit circle. All right, so let's take a look at some problems. So it says, find the length of an arc on a circle whose radius is 15 inches and the central angle is 170. So the first thing we see is that we have a central angle of 170 degrees. So we've got a problem there. We've got to go ahead and we've got to change that angle to radians. So hopefully remember how to do that. We're just going to take that 170 degrees and we're going to multiply by pi over 180. Okay, when we do that and reduce, we end up getting the angle is 17 pi over 18. Okay, so that right there is going to be my theta. Okay, so if I'm talking about the length of the arc, that's the formula S equals R times theta. We know the radius is 15 inches, and we just calculated the angle in radians. That angle is 17 pi over 18. If we go ahead and multiply that on our calculator, we're going to look for two different answers. The first one is an exact answer. So the exact answer does not have decimals, and it has pi in it. So if I were to multiply straight across, put this over 1 and multiply straight across, this would reduce to 85 pi over 6. So you can just use your calculator, do 15 times 17 divided by 18, and hit math, enter, enter. So our exact answer is 85 pi over 6. And again, it was arc length, and our unit of distance is inches. So it's going to be 85 pi over 6 inches. Okay, if we plug that into our calculator and actually multiplied by pi using the pi button, we would get approximately 44.5 inches. Okay, so your homework tonight or homework over the next couple days is going to ask you for an exact answer, which would be the 85 pi over 6, as well as an approximate answer, which in this case would be 44 pi over, or 44.5 inches. All right, so the next example, it says a clock has a 4-inch long minute hand. What is the area of the sector that is swept out after 37 minutes? All right, so one thing we have to remember here is the minute hand. Is the minute hand a radius or a diameter? So if you think about a typical clock, it's got the minute hand, it's also got the hour hand, but remember that minute hand goes all the way up to the top of the circle. So that 4 inches long right here is my radius. Okay, it's not the diameter. And we're looking for the area that is swept out over 37 minutes. All right, so let's again think of a clock. If I were to erase these minute hands here, and if I were to think about 30 minutes, okay, 30 minutes starts here, and it would go from the 12 all the way down to the 6, right? That would be a half of a circle. So the angle measure would be pi, right? I took 2 pi, I cut it in half. Because it was 30 out of 60 minutes, it was half the circle. So to find our theta for 37 minutes, we're going to do the same idea. We know that it's 37 out of 60 minutes. Okay, so it's a little bit more than half. And then we're going to multiply by the whole circle, which is 2 pi. Okay, so what does that give me? That gives me 37 pi over 30 radians. And that's my theta, or that's my angle. So anytime you're given a unit of time, we know that a full circle around or a full 2 pi is 60 minutes. So we just have to take that fraction of the 60 minutes. So if it was 10 minutes, we would do 10 over 60 times 2 pi. If it was 27 minutes, we'd do 27 over 60 times 2 pi. So then we've got to go to our formula, and we're going to do area, which is 1/2 r squared theta. So we know it's 1/2. We know the radius is 4, so it's 4 squared. And we know our angle is 37 pi over 30. Type that all into our calculator, hit math, enter, enter, but leave the pi out. And you should end up with 148 pi over 15. Okay, and again, our radius was measured, or our minute hand was measured in inches. So this is going to be area, so we know it has to be inches squared. So there would be my exact answer. If I type that into my calculator and multiplied by pi, I would get 30.997 inches squared, or approximately 31 inches squared if I had to round, to the nearest tenth or the nearest hundredth. Okay, so again, we've got an exact answer, which has the pi in it and no decimals, although I would accept like 1.5 pi is fine, but it doesn't have a decimal. You don't have to round it at all. And then the approximate answer would be rounded. I think on the homework I had you rounded the nearest hundredth, if I'm not mistaken, but realistically you could round to any unit you were told to. All right, a couple things that we need to keep in mind. One is that in the homework, again, I ask you to show the exact and the decimal answer. You should be able to come up with both, depending upon what you're using it for. you know, if I was talking about the length of something and I was going to go build, you know, a fence maybe around a circular pool, I wouldn't go to Home Depot and say, oh, I need, you know, 25 pi over 7 inches, you know, square inches inches of fencing. Okay, you would actually have to come up with a decimal approximation. So there's different times when maybe a decimal is better than the exact answer. So we're going to make sure that we can find both. One other thing is that a revolution, right? A revolution is the same as a rotation. So we're going to talk about some things, maybe a tire spinning. We know that we have a full revolution, or maybe it makes 30 revolutions in so many seconds. We know that one revolution, which is the same as a rotation, would be equal to 360 degrees, or if we're talking radians, 2 pi. Again, I think that's something that you would realize, but one revolution is the same as one rotation, which is 360 degrees or 2 pi radians. And then the last thing, which is super important, and you will lose points for it on the test, include units in all of your answers. Okay, so we got to make sure that whenever we're doing a problem, we're thinking about what the units need to be, and we've got to make sure that we include the units in all of our problems. All right, so next example says, find the radian measure of the central angle of a circle whose radius is 27 inches, and it intercepts an arc length of 6 inches. Okay, so this time we actually know the arc length and we know the radius. We're looking for the angle. Okay, so we're still going to use the arc length formula, S equals R times theta, but this time we're not solving for the arc length. We know the arc length is 6, we know the radius is 27, and we're looking for theta. Okay, so all we have to do is we have to divide both sides by 27 just to solve. Okay, so we get 6 over 27, which would reduce to 2/9. Okay, so again, we've got to think about what 2/9 or what that theta is measured in. And we know theta in all of these problems has to be in radians. So I know that my units have to be radians. So it's really important to think about what we are talking about. In this case, we're talking about an angle measure. And we know when we're doing arc length and area that that angle measure must be in radians. Okay, so that's 2/9 radians. Okay, next one says, a person when standing vertically can swing his or her arm in a plane perpendicular to your shoulder through 3/4 of a revolution. So I've kind of got a picture off to the side of what that would look like. You can start with your arm straight up and you can swing that arm about 3/4 of a full circle or of a full revolution. Okay, if her arm is 54.3 centimeters long, find the length of the arc traced by the fingertips. Okay, so again, we've kind of got a picture there. You can't do a full circle, but we're trying to figure out how big is that arc that is traced out by the tips of the fingers. All right, so again, that arc, that's the arc length. So we're going to do S equals R times theta. Okay, so we know the radius, or your arm, which is acting as the radius in this picture. The arm is 54.3 centimeters. Okay, we know that the angle is 3/4 of a full circle or a full revolution. So to find that theta, we have to do 3/4 times 2 pi. Okay, so that theta gives us, if I reduce here, that gives us 3 pi over 2. And again, that is in radians. Okay, so we're going to take that 54.3 and we're going to multiply by 3 pi over 2. So that final arc length, if I take my calculator and I do 54.3 times 3 divided by 2, and I hit math, enter, enter, that gives me 1629 over 20. And I can't forget that pi. Okay, now I could also do 81.45 pi. That would be okay too, because it was a nice decimal. Either one of those answers would be acceptable. Since we're talking about arc length, it's a distance, and our distance was in centimeters, so both of those would have to be labeled centimeters. Okay, if I really wanted to find what the decimal approximation is, I would just take that and multiply it by pi, and that would give me 255.88. So 255.88 approximately centimeters. So there's a bunch of different ways we can write our answers. If I said an exact answer, I would accept either of those in this box. And then if you wanted an approximation, it would be the one in the bottom box.